Hello, my name's Carlo Manfredini. I'm from EMONA Instruments. I'm the R&D Director. For 20 years now, EMONA Instruments has been making telecommunications teaching products and selling them all around the world. We're here at NIWeek for the second time, showcasing our EMONA Datex board. It stands for Digital Analog Telecommunications Experimenter. This is a plug-in board for the NILVIS platform, which allows students and professors to implement an entire first and second year telecommunications course with a single board. The way that we're able to do so many experiments is our unique block diagram approach. In the same way that LabVIEW is a lot of code blocks that you patch together to build a program, our board is a bunch of mathematical individual circuits that are completely independent until they are patched together using these simple wires according to the block diagram. Here, for example, I have an amplitude modulation block diagram, a very essential step in learning about comms, where you can see an oscillator, an adder, a multiplier. The adder has 2 inputs and 1 output, and it's implemented here as an adder block on the circuit. So the student patches the signal to one input of the adder, the DC to the other input, takes the output off to a multiplier, and so on and so forth. Using this block diagram approach, you have the ability to implement 30 experiments on a single board trainer. This is volume 1 of our manual. Volume 2 has a few extra experiments as well. And then another interesting thing about this experimental approach, the students are very hands-on in controlling all the parameters of the experiment. And so they take a great deal of responsibility, and they get a really good learning kick, and they feel good about building the experiment themselves. As well as controlling the experiment manually, when they flick this switch, the board goes from manual mode to PC mode, which basically means all these knobs and switches are now controlled directly from LabVIEW, from the PC. So this is a stepping stone which allows the students to now start to get involved in computer-controlled experimentation and hardware-in-the-loop experiments. So we have a LabVIEW program that can actually control the individual gains and sweep the functions and create all sorts of different telecommunication systems. Basically, we're finding this to be a very popular platform because it's so portable, because it's so comprehensive. And as well as that, this year we're pleased to announce our Photex board. Here we have a hot off-the-shelf prototype where we teach fibre optics principles on a single board. It's a very convenient introduction to important principles of fibre optics, such as a conversion from electrical to optical, and then we can implement bidirectional communications and wave division multiplexing experiments on simple, easy to use, safe fibres, so students can get an introduction to fibre optics in the communications context before they go off and do their advanced fibre optics programs in the more dedicated fibre optics lab. In the future we hope to have more boards, and that's what we have at the moment. So thanks very much for your time.